Okay, hello. So today I will show you how to do PWM, okay, or pulse width modulation. So PWM is quite popular for power electronic, for buck boost, anything that use a single switching on and off and control with duty cycle. Okay, so if you use Arduino, okay, the PWM produced is actually the frequency is very low. Let me check first. Okay, you can see here the Arduino is only switching at 490 Hz. But if you run this, okay, use it for the power electronic application for buck converter, boost converter, buck boost converter, okay, basically you cannot run the system because the frequency is too low. So basically when you search Arduino PWM frequency, basically you cannot just search like that because the frequency is fixed. But in the power electronic is usually in kilohertz, okay, usually around 20 kilohertz to 100 kilohertz normally, okay. But for the default PWM you will get this, so you basically cannot use the original code. So to avoid this problem, okay, normally happen to the student, so you have to use a modified code that can run the frequency higher. Okay, so how to do that? So you just open this link to download the library because you need the specialized library to do this. So write tiny.cc/pwm. I hope this link will be available until the end. I'm not sure whether it is will available or not until the end later. Okay, so you just type tiny.cc/pwm. okay, so you can download here. Okay, you download all. Okay, so basically this is what you get. You extract this and you get libraries and PWM generator. So for library, you have to manage the library first. You just right click, copy this and go to your document. You will have a Arduino by default, Arduino software, Arduino Uno. Where is Arduino Uno? Okay, so this one. Okay, Arduino Uno will automatically create a folder called Arduino inside your document. So click here, you can see there is a library, and then you just paste the PWM folder inside here, so it will become like this. Okay, don't touch anything here, you just paste the library. That is the first thing that you have to do. And then the second one is open this one. This one is basically the code. Okay, so when you open the code, okay, so you can see this is the very basic code. Basically it's just a code without any modification. So based on this, you can just modify to create a MPPT or anything as OPI controller or something. But this is the basic code. So I will explain how to understand this. So you can see here, integer, this one, the first one is switching frequency. If you want to change the frequency, you just change this. So this one is 70 kilohertz. Okay, you can change it maybe 20 kilohertz. I give you example 20. Okay, or and this state I set it to 70. Okay, and then you have D in and D out. Okay, D in is basically in the format of from 0 to 100%. Okay, usually in duty cycle we use 0 to 100%. But the problem is the Arduino cannot understand 0 to 100%. So you have to convert it into the 8-bit format. So basically it become, instead of 0 to 100, it becomes 0 to 255. So for this case, make sure the 100 is in the float format and this one is integer because bit cannot be point form. Okay, and then this one is the PWM pin. Okay, PWM pin, which pin that you want to produce the PWM. So this one you have to check first. Okay, at the for example Arduino Uno, if you use Arduino Uno, you can see that PWM can be produced from to pin 2 to 13. So you just have to look, okay, at the board, or you can look at the internet. Okay, so for this case I just choose pin number 10. And then this one, no need to understand, this one is just to set up the timer. Okay, and this one, if it is success, pin 13 will light up. This is just to confirm that the PWM is success. Okay, so this one is no need actually, but this one is important. Okay, so you have to include this. And then this is the where you put your code. So you can see here D in, I set it to 30% duty cycle, and then it convert the D in into D out. D in divide by 100 because it's 100%, and multiply by 255 because it is 8-bit. Okay, 255 maximum. And then you send the D out here and the PWM pin. So the pin is 10. Okay, and then you put some delay. This one is just to avoid any noise problem, but this one you can just remove this depending on the application actually. Okay, so that is the simplest way to do PWM. Okay, so you just, for me, I just upload this. Okay, so still uploading. Maybe I pause this first. Okay, now it's done uploading. Okay, I will switch to different camera later. Okay. Okay, so when it comes to coding, of course you have to verify. Okay, so verify is you have to verify with the hardware. So you have to connect the coding into the computer, the Arduino. Okay, and then you have to check in the oscilloscope. So if you look here, the frequency is 70 kilohertz. Okay, and then your duty cycle is 30%. So you have to verify with the oscilloscope. Of course, you have to set up the oscilloscope first. You go to the measure button, okay, and then you set the source, and then you select the frequency here. Okay, channel, okay, because I use channel 1, I set channel 1, and then I check the frequency, and then of course I have to press measure, and second one is the peak to peak. You have to make sure that the peak to peak is correct, and then the duty cycle, of course you have to check also. So channel 1, and then just select this one until it show duty cycle. So if you look here, the frequency is 70 kilohertz, which is correct. Okay, for hardware is usually doesn't very accurate. Usually it's not 70 kilohertz accurately. There will be some error. Okay, and then the duty cycle also the same. So you can see it is around 29%. Okay, should be okay. So if you want to check the other duty cycle, you have to change here. For example, 60%. Okay, so 60%, I implement it back. Okay, so wait for the upload done, and you can see here 70 kilohertz stay the same, but the duty cycle changed to 60%. So if this occur, this means that your PWM is accurate. Okay, so that's it. Okay, make sure you check. If not, it is not logic, it is will be fail. So make sure the timer is correct. So this one is the timer. Okay, you adjust it. Oh, okay, make sure it's not too large, not too small. Okay, and the signal is also square wave. Okay, that's it. Good luck with your PWM.